removed and no other group take their place, right? And if two groups are removed, no group come in their place. So actually what happened to the two bonds through which the two groups were connected? What will happen to them?
Will get separated, sir.
They will
Will get separated, sir, in the H and Cl.
yeah, H and Cl will, but what will happen to these two groups to which the H and Cl are connected?
They will join together, sir.
And they will give you a double bond,
Yes, sir.
right? So elimination is what actually? Elimination is removal of permanent removal of two groups, and no group come and occupy their position, and there is a double bond formation between those two groups. Okay, that is called elimination, right? And
Yes,
these
sir.
elimination reaction actually compete with substitution reaction. Okay, if this is a Y and if it is attacking on the carbon atom, and if it is displacing a group, then it is nucleophilic substitution reaction. Okay.
Yes, sir.
But if it is a Y and it is coming and extracting the H plus, and the electron are coming and the X is removing, then I'm calling it the same Y as a base. Okay.
Yes, sir.
So base is something which abstract. So for elimination, you require a strong base first of all. Is it clear? Base and nucleophile can be same or they can be different. Okay, if the same thing come and attack H plus, then it is called as a base, right?
Yes, sir.
So I need a base, OH minus, and a strong base, NH2 minus, ETO minus, ethoxide, tertiary butoxide. There are a lot of bases available. So base will take away the H plus, the electron of the H plus will form a bond with the other carbon atom and the Cl will come out. So that is actually the elimination reaction. Okay. And one more thing, you require a base and you require heat also. Right? Why do you require heat in elimination reaction? So you will find a delta written in elimination reaction along with the base in many cases. So why do you require heat?
Sir, because base is not very reactive.
No, sometimes you can take strong bases which are very reactive, very strong bases. NH2 minus is a very strong base. Okay, so heat is required. Actually, this alkene is forming. This alkene is actually having a weaker bond. Okay. So if you see the energy profile, this is going to be an endothermic reaction. What's the sign for the delta H for an endothermic reaction? Delta H is positive.
Yes, sir.
Is it clear? So it is heat absorbing reaction and it takes in heat. Okay, so that's why it is elimination reactions are favorable in the presence of heat, right? And now also we can classify elimination as E1 and E2 depending upon the sequence of removal of H and leaving group and formation of a double bond. Is it clear? E1 and E2 also we can do.
Yes, sir.
So what do you understand by E2 reaction? What happened in SN2? You can recall that.
Sir, negatively charged nucleophile approaches nuclear and
Yeah.
nucleophilic center of a substrate
Yeah,
and center of a substrate, and in this process it will reverse the
yeah,
configuration
yeah, exactly.
of the stereo center, and it will get attached while
Yeah,
removing the leaving group.
yeah, exactly, exactly. So in SN2, was all this thing happening in one by one step or all happened simultaneously?
One single step, sir.
Single step, yeah. Okay. So in elimination, what is happening? The base is coming. Okay. It is removing the H plus. Okay. From the carbon atom adjacent to the carbon atom bearing the halogen. Okay. And if the H plus is coming out, where these electron are going? The electron are forming a bond with the nearby carbon atom. Okay. And the Br is coming out. Is it clear?
Yes, sir.
So everything happened in just one step. So what all we did? Base attacked H plus, right? So base started forming a bond with H plus. These electrons actually moved here. Double bond started forming. Br started breaking, right? So it is just like SN2. It is bimolecular elimination. All the things are single step happening simultaneously. In SN2, you require what kind of nucleophile is required in SN2 reaction? Weak nucleophile or a strong nucleophile in SN2?
A strong nucleophile, sir.
Strong nucleophile, yeah, because you need someone to go and start the reaction, push away the leaving group. In the same way, here also you require a strong base in E2. E2 is bimolecular elimination reaction, attack of base, abstraction of proton by base, formation of pi bond, departure of leaving group, all are happening in a single step simultaneously. Is it clear? So it is single step, and because it is so for that the base molecule and the substrate molecule need to collide with each other. So the rate is actually directly proportional to the concentration of each one of them, and you require a strong base. Is it clear? This is single step transition involving abstraction of H from. This is alpha beta elimination. Alpha is the carbon atom which is directly connected to the leaving group, and this is the beta carbon atom. Is
Yes,
it
sir.
clear?
Yes, sir. Could you
So
show the
all this,
last slide as well, sir?
yeah, all these eliminations are known as alpha beta eliminations. Okay,
Yes, sir.
alpha beta means the two groups are removing from the adjacent carbon atoms, right?
Yes,
Alpha
sir.
beta. Okay. So yeah, just note it down. So rate. So it is actually it competes with SN2, right? I will
Yes,
tell
sir.
you when will SN2 happen. When will what are the factors which will help you to know whether the SN2 is happening or E2 is happening, right?
Yes, sir. Sir, could you show the last slide as well, sir? Just for a second.
Yeah. So this is alpha beta elimination, 1-2 elimination. That's what I said. And yeah, this is written over here. Single step transition state involves abstraction of H from the carbon atom adjacent to the carbon atom bearing the halogen leaving group. So this is alpha carbon atom. Okay. Alpha carbon atom is the carbon atom which is connected to the halogen.
Yes, sir.
And the beta carbon atom is the carbon atom which is next to it. Is it clear?
Yes, sir.
So the base abstract H plus from beta, and from alpha actually halogen is removed, leaving group departs. Is it clear? So that's
Yes,
why
sir.
it is called alpha beta elimination reaction.
Sir, one question, sir. Can you say what is a base again?
Base and a nucleophile. they are just like two sides of a same coin. Okay. Suppose I will give you example. With aqueous KOH, the Cl will be displaced and SN2 will happen. This is SN2 reaction. So this OH minus is a base or a nucleophile?
Sir, it is a nucleophile.
It is a nucleophile because it is going on attacking on the carbon. Okay. And suppose if I take alcoholic KOH. KOH alcoholic means dissolved in ethanol and heat. So this base will come and abstract H plus and Cl. Now I am calling it as a base. Why?
Sir, because it takes away the other group as well. It
It
takes
takes
away
the,
the hydrogen and
it take,
does not
yeah,
stick
H
into the.
plus. H plus. Which other group? The H plus. Okay.
Yes, sir.
Is it clear?
Yes, sir.
So if something attacks H plus, that is called a base. But if that something goes and attack on the carbon atom, that is called a nucleophile. Okay. Why the rate is directly proportional to the concentration of base and nucleophile?
More number of base molecules, more
Act-
elimination can take place.
yeah, actually both are colliding for the reaction. And if you have more concentration, they will collide more and the rate will increase. So rate is directly proportional to, just like SN2. In SN2, we were also having the same thing. The rate was directly proportional to the concentration of the substrate as well as the concentration of the nucleophile. If concentration of substrate is doubled, the rate will get doubled. If the concentration of the nucleophile, or here in this case it is a base, is doubled, the rate will get doubled. And if both are doubled, the rate will become 4 times, quadruple. Clear?
Yes, sir.
Yeah. So this is actually single step elimination reaction. You require a strong base, then only it can happen in a single step. But if you take a weak base like water, then it can't happen in a single step. So what was SN1 reaction? Tell me.
Sir, SN1 reaction.
And what kind of
the-
nucleophile promoted SN1? That also you can tell.
Sir, weak nucleophile.
Yeah. So weak nucleophile will not go and attack on its own. It will let the substrate break slowly. Okay. And that substrate will break slowly and carbocation will form. Right.
Yes, sir.
Once the carbocation formed, then nucleophile got involved in the reaction. Okay. So for even elimination also. So till the main step in SN1, only the substrate molecule was getting involved. Only substrate molecule was involved in the main step, that was departure of leaving group and all, right? So here also in E1 also it is the same thing. So even also you take a very weak base, and weak base is just like a solvent, like water, ethanol. Okay, it will not go and attack H plus on H. So that is, you cannot expect. So, but
Sir,
what
here
will
also
happen?
it is the polar solvent, sir.
Here also it is.
Polar solvent.
Yeah, polar protic, exactly. And half of the mechanism for even an SN1 are same. Okay, so polar protic solvent that helps in breaking the substrate into plus and minus that help in breaking, and you also provide heat. Okay, so you end up with a carbocation and Br minus comes out slowly. Okay, this step is same as the step which we have seen in SN1. Now what will happen? Now this water molecule, if it goes and join itself to the carbon atom, then it is SN1. Then it will become substitution where the Br minus is displaced by OH. But if that we have seen in SN1, but if this water molecule goes and attack on the H plus, so these electron will come and form a bond with H carbon plus. Okay, it will be an elimination. Clear? So this is E1. Why it is called E1? Tell me.
It is similar to SN1 reaction.
Yeah, similar to unimolecular. Yeah, elimination. Initially, this is slow step. Only one molecule was involved, and rate is directly proportional to the stability of carbocation. So this reaction can happen only at the place where the carbocation, stable carbocation, can form. Is it clear?
Yes, sir. Sir, could you show the last slide one more time, sir?
Rate is directly proportional to the stability of the carbocation.
No, sir. Could you show the last slide? Just the E1 and E2 reaction.
Yeah.
Before one, sir.
This one?
This one, sir. Yes, sir.
Yeah, this is the substitution and elimination.
Yes.
Right?
Done, sir.
Yeah.
Yes, sir.
So here the rate is independent of the concentration of the nucleophile. Because nucleophile is coming only after the climax is already over. This first step is the climax. How quickly the leaving group comes out, how quickly the carbocation forms, how stable a carbocation is. Okay, then, and if that is stable, then even can happen very quickly. Is it clear?
Yes, sir.
The nucleophile is coming in the second step. That is the fast step, and that will not change the rate of the overall reaction. Right?
Yes, sir.
So everything is written abstraction of formation of pi bond occur in the fast step. Okay, that is even. Actually, in alcohol ether, you might have studied, if you have studied in CBSE, that alcohol ether, the elimination of water, acid catalyzed dehydration of alcohols is actually even elimination.
Yes, sir. It just said it's elimination reaction. It didn't classify even.
It was even. Okay, because the
Yes, sir.
OH get protonated, it comes out and it is even. It is a famous even reaction. Okay, so dehydration is the rate of dehydration is also proportional to the stability of the carbocation. More stable a carbocation is, okay, more stable the even can happen. Okay, and suppose if someone asks you which alkene you are going to form, if there are two possible alkenes,
One which is having greater saturation,
one which is having
greater substitution.
more substituted alkene is a major product, right? And what
Yes,
that
sir.
alkene is known as?
This is rule is known as Zaitsev rule.
ZZ or ZZ.
Yes, sir.
Yeah. So why it is so? Why a more stable alkene is formed as a major product? Because more branch alkene is going to be more stable, it is going to have less energy, and it is going to form very quickly.
Yes, sir.
That is why a major alkene which is going to form will be the more substituted, more branched alkene, right? This is clear?
Yes, sir.
But it is not
Yes.
always that more branched alkene is more stable. Sometimes less branched alkene can also become very stable if you have a phenyl group. Yeah.
Sir, what is NEET?
Ethoxide, this is a base, sodium ethoxide,
Yes,
just
sir.
like hydroxide. Na plus and O minus CH2 CH3. Just like OH minus, this is going to be a stronger base.
Yes, sir.
And what is going to be the answer, final answer to this?
Sir, it will be phenyl, CH, double bond, CH, single bond, CH,
Yeah,
and branching to two CH3 groups.
yeah. Major alkene is the less substituted alkene. Why? This is less branched. Okay, and that one is more branched. If you form, this is beta, this is beta dash. From where the hydrogen is going to get removed. Beta or beta dash?
So what is beta beta dash?
No, I'm just calling and the carbon as beta carbon and beta dash carbon.
So more substituted is beta, sir.
More branched.
More
need to-
branched is beta dash.
Yeah. So which one is the final product? This one is having two alkyl group, this one and this one. And this one is having three alkyl groups. One group, this one. Another, this one.
So beta dash,
Yeah. Which one is going to be the major product?
beta dash, sir.
No. Still, this one is going to be the major product.
Yes,
This
sir.
is the set the alkene. So every
Sir,
time
what
it
is,
doesn't.
substituted?
Yeah.
What is the meaning of substituted here, sir?
More substituted means more branch. The one which is having more alkyl group. So more substituted, more branched alkene. You need to you need to count the number of alkyl group directly connected to the doubly bonded carbon atom. Okay.
But then in the second case, there will be more, right, sir?
Yeah, the second case will be more. Yeah, so it is just the actual superficial statement. Okay, it is just the superficial statement that, so it is most of the time it is true. That's what I want. I have given this example just to make you understand this. So it is just the superficial statement that the more branched alkene is more stable. That is true for most of the cases. More the number of alkyl groups, more stable the alkene is going to be. Is it clear?
Sir, so
What?
in actuality, which one should be? How
Yeah,
will how will
yeah.
it measure?
So in most of the cases it will work. But suppose if you have a phenyl group, benzene ring coming, then you should go for the side. Then you should go for the side on which the benzene is connected. Why benzene is so special? Actually, why? Yeah, why you? why you were making more branched alkene? Why you were making more branched alkene? What was the reason? Because you wanted to make it more stable. Okay, that was the reason, right? So more branched alkene, more branched the alkene which is having more number of alkyl group is more stable. That is true. But suppose if you are having benzene on one side, then you will give priority to the benzene. Is it clear or not?
Can you say it again, sir?
Why benzene makes the alkene stable?
Because of resonance?
Yeah, because of resonance. Because benzene has 3 double bond. And if there is a double bond just outside the benzene, which we are forming by doing the elimination, that double bond will overlap with the double bond of the benzene, and there is a mixing of electrons. Okay, and that will give more stability than the alkyl groups. Is it clear?
Yes, sir.
So actual thing is you should make a more stable alkene, right? That is the actual thing. In most of the cases, most commonly the more branched alkene is more stable. But sometimes a less branched alkene can also be more stable if there is a group which can stabilize the double bond, just like benzene. Is it clear? I hope you are not confused and you will not make mistake.
Sir, so most of the cases this is true.
In normal alkyl groups, if the groups are normal alkyl groups, you are going to make an alkene which is more branched. I will write one more example here to make you understand. So this is the ZF alkene. Is it clear? This is the major alkene,
Yes, sir.
right? And this is the minor. What is minor alkene known as? Often, right?
No, sir.
Here, this is often alkene, and the major is ZF. So now, so this is, I hope, clear to you, right? This is the answer. And suppose if the same question come with the methyl groups. Yeah, now tell me. Yeah, from where you will remove the hydrogen, beta or beta dash? Yeah, Nabil.
So we will remove it from beta dash.
Yeah, now from beta dash. Why you are not removed from beta?
So because beta dash will be more substituted.
These are normal alkyl groups, so I will prefer to make a more substituted. But in this phenyl, I chose phenyl. Okay. So I hope that is clear,
Yes,
right?
sir.
And now, yeah. You can compare the rate of elimination. More branched will have more rate of elimination. Okay.
Yes, sir.
Is it clear?
Yes, sir.
Okay, so more and more branching means more and more the alkene which you are going to make is going to become more and more branched, more and more stable. So it is going to form very quickly. Okay, that's the reason, right? So yeah. Let's do this. Yeah, what's going to be the answer? What you are thinking, tell me. Only one alkene. Suppose if someone asks you possible alkene, then you will just see wherever the one alkene is possible.
Sir, B, sir.
B, yeah.
Yes, sir.
So there will be no set there, Hoffman, it will be very symmetrical. Is it clear? Right? Because it will be just cyclohexane. And which one will give you maximum alkenes? How many alkene will be obtained by A, B, A, C, and D?
Sir, A, we can obtain 3, sir.
A will give you how many different
Three.
alkenes? 3? No, only 2.
No, sir, only 2.
Because these two are same. And here also,
Similarly, D of 2, sir.
yeah, only 2. This is going to be the major. And here also D also only 2. Right?
Sir.
Here,
Yes, sir. Oh, 1 minute, sir. Can you show that? I will just note it down. Done, sir.
what's
Sir, is
going
it
to
D?
Yeah, it is D. It is the same concept which we studied in the above question. Right?
Yes, sir.
Okay. So this is from AIMS. question earlier that names used to add a separate examination.
Sir, what is OTS?
OTS is sulfonate, toluene sulfonate. Actually, it is a very good ligand. So how the product is formed?
Sir, nucleophile substitution.
Is this a substitution reaction or elimination?
Sir, elimination. Sir.
This is an elimination reaction. Yeah.
Sir, so is it C, sir?
It is C. Yeah, correct. Good. So is it clear now?
Yes, sir.
The reaction overall seems to be very difficult. Okay, but it is easy if you know the concept. Okay.
Sir, could you just show the earlier one? Yes, one more time, sir.
Yeah.
Okay, sir.
Shall I move ahead?
Yes, sir.
Sometimes what happens, suppose if we try each and every option, it may take long time. But sometimes if we apply the trick, it can become very easy.
Sir, what is the difference between elimination or direct only elimination reaction?
Actually, what this question is saying, which of the following compounds shall not produce propene? Means which of the following will not give you propene? So first you are reacting the given compound with HBr and then doing the elimination, or if the compound given on which you can directly go for elimination reaction. So either by direct elimination or by addition of HBr and then doing the elimination, where you are not going to get a propane. Understood the question?
Yes, sir.
Yeah.
Sir, B, sir.
Which one?
Sir, B.
B?
B, sir.
No. Because B, if you react it with HBr, it will get converted to bromide, right?
Which one will not form? Okay, sir.
Yeah, which one will not? And bromide will come, and then you will do the elimination, right?
Sir, so C we can say, sir.
Yeah, C. Exactly. And here, by directly doing the elimination, you can get the propene. But in C, you can't get the propene because there are no 3 carbon atoms. Clear or not?
Yes, sir.
That is quickly you can decide. Okay. So this is Williamson ether. Have you studied? Williamson ether synthesis. Alcohol. Yeah, tell me, Nabil. Nabil, have you studied Williamson ether synthesis in alcohol?
Yes, sir.
Yeah. Okay. So yeah, this is the same, but why I am discussing it there, because it is actually the mechanism. You need to know whether it is substitution, whether it is elimination, which one is happening where. So tell me if you want to make, okay, if you want to make this ether, or I can take a new page. Which alkyl halide you should choose? Which alkyl halide and which alkoxide you should choose? Remember it? Can you use this one? This option?
Yes, sir. Yes, sir.
Is it correct?
Yes, sir.
So substitution will happen. Is it correct?
Yes, sir.
No, it is not correct.
SN1 reaction, right, sir?
No, but SN1 can't happen because you are taking a strong.
Eliminations.
Yeah, so because you have taken a strong base, that will have a tendency to go and attack directly.
Sir, how to identify if it is a base or a nucleophile in the reaction?
Yeah, actually, you need to think whether, suppose there are many things you need to look at. One is a substrate. So can SN2 happen here?
No, sir.
Why?
Sir, because it lead to formation of tertiary carbon atom, and SN2 is very less reactive towards tertiary carbocation.
Yeah. So if SN2 will not happen, what will happen?
SN1 or elimination?
Yeah, no. If SN2 if you have taken a strong nucleophile, okay, and if SN2 is not able to happen, then E2 will happen.
How to see its strengths of the
For
nucleophile?
example, this nucleophile is prevented from going and attacking on this carbon. That you know. So SN2 can't happen. But SN1 also can't happen. Why SN1 can't happen? Because you're taking a strong. This is minus. Okay.
Yes, sir.
So it will go and
Sir,
attack.
how to know,
Yeah.
sir, how to know whether a nucleophile is strong or weak, sir?
Suppose if you have taken CH3OH, it is a neutral molecule. Will you expect the CH3OH to go and attack? Go and fight with someone? Or you expect CH3O minus to go and fight with someone?
O minus.
Yeah, O minus is more aggressive. And this is more relaxed. Is it clear?
Yes, sir. So if it is having, if it
Yeah,
is a stable molecule, it is a nucleophile. If it is a like ionized or having
yeah,
a charge, most likely it is a base.
yeah. It will become, yeah, it is a base or it can be. So now you need to look at the structure of this. So if it is a strong, then the mechanism will be bimolecular, SN2 or E2. Clear?
Yes, sir.
Because bimolecular means now two molecules will be involved. Okay, how two molecules will be involved? Because it will go and start attacking. So, but if two molecules are involved, will the substrate molecule, will it allow SN2 to happen? That depends. If it is primary, then SN2 can happen very quickly. But if it's tertiary, we know SN2 can't happen. So if SN2 can't happen, what will happen then? And you have taken a strong substance which will go and attack, and SN2 is not happening, then what will happen?
E2, E1, sir.
Yeah, then E2 will happen. Okay, not even. Even and this is for E1 and SN1. Okay. If it is heat, then E1. Okay. And this is for E2 and SN2. If it is tertiary and heat, alcoholic, then it is E2, not SN. Clear? Getting it? So let me show you one example. This one only. So how much you are getting? Tell me. If you are not getting, do let me know. Okay, don't worry. So here SN2 can happen or not? First tell me this. SN2 can happen or not? This is tertiary.
No, sir. No, sir.
SN2 can't happen because it is very much crowded. But there is the branching, excessive number of alkyl groups will not let the SN2 to occur here. But the branching is making the alkene more and more stable. Is it clear?
Sir.
So if the branching is making more and more stable, then E2 will happen. Okay, so on tertiary, no SN2.
Sir, here why SN1 won't happen, sir? Because it is a
SN1,
strong.
because you have taken an aggressive substance. Suppose if you would have taken this one. And definitely SN1. You are not forcing this. This is relaxed. This is neutral. This is not going and attacking. So what will happen?
Sir,
This
so then
is
why won't E1 happen, sir? In that case,
why
E1 won't happen, sir.
even will
In
also
the
happen if you would have taken heat. because elimination require heat.
So sir, in the CH3O minus plus tertiary third bromide,
This
why?
one,
Yes sir. In
no,
that, why we choose E2 over E1 sir?
yeah, E1 can't happen because here it is going and attacking directly. E1 is actually again like SN1. That's what we discussed today. You need to take a nucleophile which is very relaxed, which is not going and attacking. That's why it is SN1. One means what? Only one molecule is involved. If you take a strong molecule like this, unstable, which is minus, so this will get involved and it will become E2. Is it
Sir,
clear?
but you said, yes sir, but you said the difference between a base and a nucleophile was that base is stronger as compared to nucleophile, right,
Yeah.
sir?
No, actually, it depends upon the substrate also. It depends upon the substrate. Suppose if I take the same structure, let me explain you complete thing, then you will be clear. Okay. Here it is. Here I am calling the same thing as a nucleophile, and here I am calling it as a base. Why? Tell me. Now tell me. Here the SN2 can happen very quickly. Is it clear? Why SN2
Yes,
can
sir.
happen very quickly? Because it is,
Because there's no steric hindrance.
yeah, it is a very small molecule. Yeah, no steric hindrance. SN2 can happen. So it is CS, what it will be? CS3, CS2, OCS. This is SN2. Okay, this is a nucleophile. Is it clear? So both require strong. Suppose if you are doing the elimination, that it requires strong base E2. If you are doing SN2, it requires strong nucleophile. Okay, strong means bimolecular. Okay, but here what will happen? Here will you do the SN2 reaction?
No, sir.
Why?
Because of steric hindrance.
Yeah, so what you will do? And the thing which you have taken has to react. It has to react because it is unstable. It is minus. It is a very strong base. So what will
So
it do?
E2, sir.
It can't go and access the carbon atom. Okay, it can't go and access the carbon atom. So where it will attack? Now,
E2, sir.
yeah, it will go and attack on the H plus. Is it clear?
Yes, sir.
So and H plus are there, a lot of H plus, and elimination is also favored. Why elimination is favored? Because you are having so many hydrogens, right? And the alkene which is formed is very stable. Is it clear?
Yes, sir.
So elimination is actually favored. So and the alkene which is formed is very much branched, so it can form very easily. So you need in Williamson ether synthesis, you need to choose your alkyl halide very carefully. You should not take so alkyl halide which is branched. Okay, because if you do this and you expect the ether to form, ether will not form, SN2 will not happen. Instead, elimination will happen. E2 will happen. Is it clear?
Yes, sir.
So suppose if you want to make this ether, what set of alkyl halide and alkoxide will you choose?
So the alkoxide would be CH3O minus, and the alkylide will be uh, tert butyl
To
bromide,
make ether, to make ether,
tertiary alkyl Lect, sir.
to make an ether, think once again. Will it give you an ether? Ether will form if this O minus goes and join itself to the carbon. Tell me, is it going to give you an ether or an alkene? Why ether has not formed?
Because
Because
then the
what you are
reaction.
doing is SN2 and it is very much branched. SN1 can't happen here. If you have taken alkoxide, which is a strong molecule, O minus, SN1 can't happen, E1 can't happen. You need some biomolecular mechanism in which two things are involved. So you want ether to get prepared, but ether can't form because for that the O minus should go and attach itself to the carbon atom. That is not possible because the carbon is tertiary, right?
Yes, sir.
So what will happen? The O minus will go and attack on H plus. H plus will be eliminated. You will get what? You will get an alkene. So how can you make this? Now the question is, how can you make this ether without letting E2 happen? Yeah. Can I choose some another set of alkyl halide and alkoxide? Can I do it this way? CH3Br. If I break it like this, can you see this?
Yes, sir.
Can I use this?
Yes, sir.
Will it give substitution or elimination reaction?
Substitution, sir.
Yeah, it is going to give a substitution very easily. Why? Because
It is a weak nucleophile.
no, it is a strong nucleophile, but elimination can't happen here. Why it can't happen?
Because there is no beta hydrogen.
Yeah, there is no, and it is even if it is there, then also elimination will not happen because it is a very small molecule. Substitution elimination will happen only, elimination actually require more energy. So elimination will happen only if substitution is not possible. SN2 is not possible. Is it clear? Clear or not? So here O minus will come and attack and you will have CH3. SN2 can happen very quickly because it is less charge. Okay? Right? Right, Nabil? Okay,
Yes,
so
sir.
this is about your alkyl halide and aryl halide. Now, shall we start with alcohol?
Yes, sir.
So tell me how alcohols are prepared from alkenes. Yeah. How do you prepare alcohol from alkenes?
From alkanes. By
Al
treating with
alkene from alkene.
alkane or alkene, sir.
Double bond, alkene. Which is this method? Yeah.
Uh, Acid catalyst solution, sir.
Yeah, this is simply addition of water. Okay, so how can you alkanes actually why I have not taken because alkanes are considered as very less reactive. So that's why I have not taken the alkane. Is it clear?
Yes, sir.
Right. So tell me this is which reaction? This is simply addition of water only, but simply water you can't take, it will not work because water, this is water doesn't ionize sufficiently. Is water is neutral, we know. So we want H plus to be in sufficient amount. So for that we took H3O plus, dilute H2S. So You will be given with dilute H2SO4, or someone may write just H plus H2O, or someone may write just H3O plus. Is it clear?
Yes.
All are same. Okay. And all are same, and that H, so H plus will come, and it is Markovnikov addition. It will get attached to the carbon atom bearing more hydrogen. The cation will form here, and the water will go and get attached to this position. Is it clear or not?
Yes, sir. So this method we can prepare from alkenes
Yeah,
only second method, sir.
yeah. Secondary, yeah. So this alcohol you can make, no, where you will put OH and H. Is it clear?
Yes, sir.
Okay. So tell me this.
Just show that slide one more time.
Yeah.
Yes,
Yeah.
sir. Done, sir.
Yeah. So I hope you understood that Williamson ether synthesis. Okay, that is very important. Okay. How to choose alkoxide and how to choose alkyl halide. Alkyl halide should be such that it can undergo substitution. Okay, we will discuss in this also. Just you can revise it on your own. Okay.
Sir, one question, sir.
Yeah.
Can you see any good book for practicing JEE questions?
JEE questions.
Yes, sir.
Yeah. These are most of them are JEE and NEET mixed.
No,
Yeah,
sir,
I
like
can.
any book for practicing.
Any book for practicing JEE question. Yeah, you can take past JEE means. You can download it from the net or you can buy it. Okay.
Yes, sir.
MTG book, Disha book. Okay.
Yes, sir.
And Singage publication book, will that be available in UAE? I don't know. This is good.
Engage, sir.
Yeah,
Yes,
this
sir.
is good. Don't go for advanced. Okay. JEE mains. JEE mains is also very good.
Sir, in case if for advanced, you know anything.
Yeah. Singage. There are two books actually. If you want to go for advanced, go for it. Okay.
Yes,
I'm having the cover will change actually. It will depend. It is for advanced. You will have separate book for organic, inorganic, and physical.
yes, sir. Sir, but if
Be
we learn for advanced, is it good enough for me?
Actually, you are going for mains or advanced.
I thought about going for advanced, sir, but since there's not enough time, we thought, and even Asam sir told that it would be better
Yeah.
if we do means first and then do advanced.
Better go for mains first, because if you get a good rank, because a lot of my students actually uh, uh, happen that actually suppose in advance, if you get a suppose let's say little bit, because in IIT the seats are very less, computer science. Okay. 100 seats of that. Okay. So even if you get a good rank in advance, the chances of getting computer science is very difficult. Okay. Right. But if you get a somewhat good rank in mains, you can get good college and computer science, because there are many colleges. Right. Any preference you have?
Computer science.
Yeah, computer science is the best. Actually, I myself did from IIT Bombay, and then, but I was in chemical, right? Chemical engineering. So computer science nowadays has changed a lot. So better go for computer science and focus mainly for mains, go get good rank and go for computer science. But in advance, actually, that will be very difficult because very few seats are there. Okay. Clear? So, but if you can do that, once you get the mains, you have time, then you can go for advance also. I will make you prepare for that also. A lot of advanced questions are there. Right now, what I do, I try to give you basic questions so that you can do all sorts of questions, the concepts and all. Okay, I'm focusing on the basic questions. So, and some good questions also, like the OTS and all, the one which we did in elimination reactions. Okay,
Yes, sir.
right. So what will be the answer to this question? This is very basic.
Sir, A, sir.
Yeah. Okay, correct. So yeah, this we know, this we know. This is the mechanism that I already told you, right?
Yes, sir.
And yeah. So yeah, tell me this one.
Sir, it will give um,
Yeah. What's the IUPAC name? We are still doing that same method, acid catalyzed hydration of alkene using dilute H2O support. But there is one thing which you need to know.
3-methyl butane 2-all.
Yeah, you told me this one. But the answer is this one. Okay.
So,
Why? Tell me. What's the reason? Actually, in this method, there is this method occur via carbocation formation, right?
yes, sir.
And carbocation actually always has a tendency to undergo rearrangement. Carbocation, do remember this in all the chapters now, in alcohol chapter or in amine chapter. Okay, wherever the carbocation is forming, check this is a secondary carbocation. If it gets shifted to the adjacent position, will it become more stable? Are there any chances of making carbocation more stable by shifting on to its adjacent carbon? So this carbon is primary and this is tertiary. So the answer is yes. The carbocation can become more stable by getting shifted to tertiary carbon atom. Okay, but the tertiary carbon atom has complete bonds. So there should be, and what all groups are connected to the tertiary carbon? Can you tell me?
2-methyl groups
Yeah,
and
2
one
methyl,
ethyl.
1. Yeah, 1.
Ethyl group.
Yeah, ethyl. And but there are 4 groups. One H is also there. Okay. Suppose if I plan to bring the carbocation here, I need to take some group on at that position. Is it clear?
Yes, sir.
So which group will go to that position? The answer is the group which can migrate more easily. The migratory aptitude is H minus, then pH phenyl, then tertiary carbon. This is the migratory aptitude. Okay.
Yes, sir.
This tells us who can shift. The H will get shifted So this is known as rearrangement of carbocation. And you should always check for the rearrangement of carbocation. The H will get shifted to that point, and because H has moved along with the electron pair, so cation will come at this position. Okay. Here, right? And now once the cation is completely formed and it is stable, the most stable, now you can think of putting OH, because dilute condition is there. OH you can put over it. So in that way, so always keep in mind. Okay, right?
Yes, sir.
So this is going to be the answer. So the acid catalyzed hydration of alkenes by using dilute H2SO4 as a disadvantage, or you should be careful that is Markovnikov addition. Okay, and but you should be careful of the rearrangement of carbocation. Is it clear?
Yes, sir.
There are other methods also. This is oxymercuration demercuration. In short, I call it as OMDM. This is also addition of water only, but not direct addition. First, you add mercuric acetate and water. And in the second step, you take sodium borohydride NaBH4 that removes mercury and put H in its place. So overall is, you can write the step and no need to know the complete mechanism. This is Markovnikov addition. That was also Markovnikov addition, but that was with rearrangement. If it was happening, you can't stop the rearrangement. Okay, but this method, OMDM method, is Markovnikov addition. Okay, it is without rearrangement. Is it clear?
Yes, sir.
Okay, so the rearrangement will not happen. Suppose if you take the OMDM method here, then the answer would have been, so with dilute H2SO4, the rearrangement will happen and the answer will be this one. And with OMDM, but for OMDM you need to write the complete mechanism, the complete set of reagent, that is mercuric acetate, HgOCOCH3, mercuric acetate whole thrice, then water, THF is a solvent. This is the first step, followed by NaBH4. Okay, that is the complete set. But it is Markovnikov and the rearrangement will not happen. That you need to remember. That's it.
The rearrangement means no shifting of
Shifting of
carbocation.
carbocation. Yeah, shifting of carbocation. Because actually what happens here is the H plus is not directly adding, the mercury plus, mercurinium ion is adding, and the mercury plus form a close triangular cation like this. Actually, there are a lot of details in this. Okay, so I'm telling you the heart of the main thing. And this actually, cation is not open like the cation which we have seen here. So this cation was very unstable, and so it provoked rearrangement to happen. But in this case, this cation is connected because mercury has a lone pair, so it get connected from both the side and from this cation. This doesn't move here or there, just like the cation which we have seen in the earlier question. And then when you use NaBH4, this water attacks in a Markovnikov way, OH will get connected and mercury will be displaced by NaBH4. So no need for writing, no need for knowing the mechanism, but just you can keep in mind that you should do the Markovnikov addition, but you should not do rearrangements, or you should not do the shifting of carbon. That's it. Clear?
Yes, sir.
Right. So let's do this. Yeah, Nabil, what's going to be the answer to this one? Oxymercuration, demercuration, the reagent complete is not written, just the name is written. Yeah, Nabil, can you hear my
It
voice?
is,
Yeah, which,
sir,
what is that? Yeah, A is the answer, right? But if we would have taken dilute H2SO4, then this is also very common question with dilute H2SO4 also. Or H3O plus, then what could have been the answer? H plus you are going to add here. Right?
yes, sir.
The cation will get shifted adjacent to phenyl because phenyl can make the cation very stable by shifting of hydride.
Yes, sir.
So H added at this carbon, but OH is going to add at this carbon. It's simply dilute H2SO. Clear?
Yes, sir.
So that's the difference. Okay. So that was with rearrangement and this was without rearrangement. Okay. Yeah. So now can you, so okay, we can do it on the next one. Just we can quickly go through it. Can you make, can you let the OH connect on the outer carbon? Can that happen?
Yes, sir.
How?
If the outer carbon gets becomes a carbocation.
Yeah, actually, but carbocation is never formed on the outer carbon. It is always formed on the inner carbon and it gets shifted on the inner and inner side by rearrangement. So it is a new method which is hydroboration oxidation. Clear?
Yes, sir.
It is known by the name of HBO. I call it HBO. HBO, there is a movie channel also. Okay. So in this method, you get, till now we have not seen, till now everywhere the with oxymercuration, demercuration, or with normal diet. So everywhere the OH was getting connected inside. Never it connected outside. Okay, look here. The OH got connected every time the OH got connected on the inner side. Clear? More branches
Yes.
everywhere. So till now we are not having any method by which we can make the OH connect on the outer carbon. Okay, and this is now the method which is known as hydroboration oxidation. Okay, and this method is not the direct; it is actually the addition of borane and then H2 by H2O2 you remove that boron by OH. Okay, clear?
Yes, sir.
So let's cover it on the next one. This is a very important method, very important. Top priority method and asked in all the examinations. So you can